So hey, welcome back to Network Analyst tutorial. So the first step you need to do is go to Blackboard. You need to download the Network Analyst tutorial PDF. I'm just gonna open this in a new window, and then let's download the data also. Just like click on it, it should automatically download. So you see here the network analyst data is being downloaded. It's about 30 megabytes in size. So it shouldn't take you this long. So I have downloaded my PDF and the data. So I'm going to move these into my C drive. I'm going to move them into my because that's the proper location. I'm going to open my network analyst tutorial, so which should have 9 different exercises, but we'll be focusing on finding the best route. We'll be calculating service areas using and creating an OD cost matrix, and also we'll be working on choosing optimal site location, store locations, and using location allocation. So it should have a bunch of instructions for you to work through these exercises, which is very helpful. If you want to work on the other exercises, it's up to you, but this class only requires you to work on number 3, number 5 and 9, or actually 5 and 9. So let's also extract the data we just downloaded, which is actually right here, network analyst data. Right click and say, if you don't have WinRAR, it's gonna say extract or something like that. So it's gonna show you, give you like a view like this when you double click on it. If you double click and open it, you have RGS folder. Essentially, you can just like drag and drop it into your C drive like that, or if you are a little more, if you already have an RGS folder like me, don't worry about it. I'm just gonna drag and drop it into my RGS folder. So once that's done, if you don't have an RGS folder, create one in your C drive, drag it into your RGS tutor folder, and you should have network analyst, within which you have tutorial data and workflow data. So that's that. Let's minimize those windows. So what I'm going to do now is open a blank map document, and now I'm going to open my let's look at the tutorial document, what it says. I'm going to scroll down. I'm going to skip creating networks. I'm going to skip creating multi-model network, and then I'm going to scroll down to shortest route, finding the best route using the network dataset. So let's open exercise 3.mxt, which is in your C drive under RGS folder. It should be called tutor network analyst tutorial exercise 3. Okay, open that. Go ahead and open that. So you already have your network dataset, which is the street network dataset right there. So that's our network dataset, which has all the variables that we need to actually run this analysis. So the first step here is to click on customize, click on extensions, make sure you have your network analyst turned on, and then you can right click anywhere in the empty customize your toolbar space, and then click on network analyst toolbar. So this toolbar right here, I'm going to close the rest of my tool. So I'm going to show you a couple of things. The first is when you click on network analyst, you have all your solvers here. Your new route, new service area, new closest facility, OD cost matrix, vehicle routing problem, and location allocation problem. So the one you need for this is a new route, but we'll come back to that. So actually, and then there is a network analyst window. If you click on this, a new window opens. Maybe it will open something like this for you. I docked it to my left so that I have enough space. I see. We'll talk about what this can do once you add a new route. So when you actually hover your mouse on top of a new route, it sort of gives you a brief description on what it does. But I'm gonna go ahead and click on new route, and here, as you can see, there are a set of defined layers that are added automatically when I clicked on this route solver. So I have stops, point barriers, routes, and line barriers, and polygon barriers. So we'll see what those mean. So the first step here is to, let's go back to the tutorial. So what they're saying is just play around with it, create a bunch of locations, and then solve it to find the best route traveling from 1 to 3 or something like that. So okay, let's go ahead and do that. I'm going to go back to my map document. I'm going to zoom into any of these areas. So I want to create a new network location. I'm gonna click on this. I created a location for 1141 Scott Street. I don't know where that is or what that is, but I'm just gonna go with so I'm gonna assume these are the 3 points I want to sort of like go to. So what I will do is, once I added this, you see how I got my network under my network analyst window. I got my the route layer setup, in which I have 3 stops which I just created. If you will talk, and then we have point barriers. Everything else doesn't have any values. It all says 0 here. So we have 3 points, and now let's solve this. Okay, let's just solve and see what happens. So you have 3 points. Let's hit solving route. So essentially it's saying, okay, from route 1 to 3. Okay, now you have a new route, 1141 Scott Street to 735 Franklin Street. That's your route. Let's open the route layer and see what it says. It says first stop is 1, last stop is 3, and stop count is 3. Total travel time of 3 minutes. You see that? So this is your network cost, and that's being automatically calculated. So so we went with the default options. So what are some of the options that we have here? So route properties, click on the network analyst window, click on route properties, and here you can actually let's look at the general properties. It says the layer name is called route, and if you want to change the route name, you can. And then you have the following layers, following sets of layers, and what layers have features will be sort of like grayed out, or you can turn them off, so you can turn off the rest of the layers if you like. And then the source layer, and we are using within the street network dataset, which is located in the app tutor folder under network analyst, and then it's gonna give you the analysis setting. This is the main tab for you. So we are actually the impedance or cost is in travel time. If you want, you can have that as meters or minutes or any of those. And then but I'm gonna go with the default, which is travel time. If you want this to be in distance, you can go with that. You can use that too. And then you have one-way restrictions, one-way and restricted turns, and you also have options to start at control which time of the day you want to start, depending on the traffic, historic traffic data. It will give you a new result if there is any heavy traffic or anything with based on your route. And then use time windows, and if you want to like reorder your stops to find your optimal route, you can do that. But I'm just gonna turn that off. if you have multiple 10 or 15 points and you are new to the city, you don't know where to start and where to end, but you want to cover all the points, this would be the best way. And you can actually create the first point could be your hotel, last point could be airport. Essentially you can reorder everything else based on these first and last stops. That's when you would use it. And then there are different options here. You have use time attributes, and if you want to open directions window automatically, you can do that. And then the accumulation attributes, you can accumulate travel time, you can accumulate minutes, and you can accumulate meters. And then the network location properties, these properties are actually used to actually map your network locations. So it's saying whenever you click on a map, find the closest street which is within 5,000 meters. Search tolerance is what it's called. So anyways, that's for another subject. But if you want to open a directions window, you click on that and you get like a detailed direction. It's sort of like Google Maps. Using Google Maps, you get detailed directions on from where to start, when to turn, and all that. And if you want, you can insert small maps too. So anyways, if you want detailed directions. So let's solve this again since we changed some of this. Let's look at a route. So since we added like total meters, that's 2000 meters, or almost like and then that's the time. The time is the same. So what happened? Let's talk about point barriers. So what if there is some kind of a road construction right here? So you see how that's a different symbol. What if there are a couple of construction? Let's just say there is a construction there or an accident. What happens if you solve this again? So it's going to reroute you automatically via a different route. So what if there is a big flooding? Polygon barriers. Let's try polygon barrier. So there is a big polygon barrier, like a flooding in this area. And what if you solve it again? So it's gonna reroute you around those barriers that you automatically add, and then it's gonna give you the best route possible based on your cost attributes. So that's how you actually use the route solver. So let's look at a tutorial on how to create a service area and creating an OD cost matrix. So the first step is to actually opening the right tutorial map, which is exercise 5 within the tutorial folder under network analyst under our tutor folder. So just go ahead and open that. Under tutorial you have exercise 5. In this, what you will be doing is creating a new service area. You'll be loading locations from existing warehouses, and then you'll be creating a 3, 5 and 10 minute drive times from that from those warehouses, so that you know what areas are what are the service areas for those particular warehouses. So how do we do that? So this is our exercise 5 map document. You have the red ones, which are the 6 warehouses, and you have all the stores which actually for which these warehouses sort of like service. So let's create a new service area, and here under facilities, I know what the facilities is. The facilities in this case are the warehouses, so I'm gonna right click and click on load locations, and here the facilities are warehouses, and the name field is name. I'm gonna click OK here. So I got my located facilities, which are warehouses 1 through 6, and now I'm going to go to my analysis settings, in which I'm gonna say then 3, 5 and 10, right? 3, space 5 space 10, which means we are creating break values or service areas for 3-minute, 5-minute and 10-minute drive times. So also we need to create these facilities you'll specify the direction of travel will be from the facility, not toward the facility. So I'm just going to go back and say away from the facility. Also, we'll make sure that since these are trucks that will be servicing, no U-turns will be allowed. And then I'm going to click apply, and then I'm going to polygon generation. So let's look at for polygon type, click on generalized. Let's see what they mean. So generalized overlapping polygons, and then it really depends on what type of feature you want to create, whether you want to create like a cumulative polygon or sort of like a ring, like a donut looking polygon. So click on apply and click on OK, and then solve this. So once you solve this, you'll be creating service areas for these different polygons, for these different warehouses. You see there's a progress bar, and as you can see, most of this area is serviced. Unfortunately, the colors are not really good. I'm going to change the color of the last one to red so that you can see a little more. So these stores right here are not really serviced. So what that means is, so that's the problem we are trying to solve as part of the second one. So if you want, what we can do is solve it again, and then flip the colors so that the outer rings will be a little more opaque. So I'm going to go to properties, and then we can flip the colors, click OK. So that looks slightly better. And let's actually so as you can see, this is not an ideal situation here. There are a good amount of stores that are, like they're not being serviced properly, or they're too far away from a warehouse, which will increase your cost. So what we need to do is find out what is the least, which warehouses are the least efficient locations. So we need to so that we can relocate those warehouses to a much more appropriate location. So this is what we got. So let's identify all the stores which are not serviced right now. I'm going to click on select by location, and I'm going to select all the stores that are within the polygons. Let's apply. Okay, these are all the stores that are being serviced. So what we need is the exact opposite. So I'm going to right click on the stores and say go to selection and switch the selection. So the highlighted stores are the stores that are not being serviced. From a visual analysis, I can easily say that this store right here is not servicing any of the locations. So if I go and look at the polygons, or as I can see, even within this polygon right here, I don't see any store within this polygon. So this store is being sort of like wasted, or it's outside any of the, it's not really accessible. So we need to move it. So how do we do this? We actually select warehouse 2, which is this one, and I'm going to select and move this location to a, I don't know, somewhere, the book says somewhere close to these, maybe, perhaps, and then solve this again. So when you do that, when you move your store to a much more accessible location, you will essentially end up with a much better service area that's gonna serve everybody. So that's how you actually make decisions based on network analyst capabilities. So the next step is to actually identify the service area polygon that each store is within. So what we'll do is right click on the stores, or move the stores above everything first, and then right click on it, and I'm going to join these service areas based on a location. I'm going to base this on the polygons we just generated. So if it falls inside a particular polygon, it's gonna get the attributes of the polygon that it is being joined to. So which essentially means the service areas attributes will be attached to this particular store. So which is what we need. I'm going to save this in C, RGS, Tutor Network Analyst Tutorial. I'm going to save this as stores with poly, stores within poly. I'm gonna save this as a shape file. Click OK. Click OK. So if I open this attribute table, what you get is you have your name of the store, and then we have the warehouse facility and the service area, or which warehouse it is being serviced by. So this store is served by, these are the stores that are being serviced by warehouse 6, these two are by warehouse 1, and these 3 actually from warehouse 4, so on and so forth. So looks like our warehouse 6 is the most efficient one. So essentially that's this store right here. That's warehouse 6, which is this one. And then I'm going to clear this selection. The next step is to, so now that we have created these service areas, now we need to know creating an OD matrix. We need to create an OD matrix because we need to figure out which facilities are being serviced by a 10-minute drive time from the closest warehouse. So what we'll do is click on Network Analyst, click on New OD Cost Matrix, and here I'm going to turn off my service area for a minute, and also turn off my stores within poly. The origins we know are actually the facilities, right? Origins are the warehouses. So right click and click on load locations, and I'm going to load my warehouses. So this is where all the material will be distributed to the stores. I'm going to click on OK, and the destinations are the store locations. I'm going to load locations, and I'll say stores, and then the name field would be NOM, and then I'm going to click OK. So I found all my stores and origins, and then what we need to do is actually go to the analysis settings for this OD cost matrix, and in analysis settings will be the impedance is drive time in minutes. The default cutoff value is actually 10 minutes, because I don't want anything to be serviced by more than 10-minute drive time. So I want all the facilities to be within a 10-minute drive time from the closest warehouse. So just gonna set 10 there. U-turns are, click on allowed for now, and then Now output shapefile has to be set to straight line here. Also for the network locations and accumulation, if you want any other attributes, you can turn on like drive time or meters and so on and so forth. So but let's go ahead and ignore that, apply OK, and I'm going to click on oh, it says no origins have been found for a bunch of stores, actually, because the stores, this location is still based off of the original warehouse location. So I'm going to click on that again, select move warehouse 2, and I'm going to move it somewhere here. I'm going to solve it again. So let's look at the lines. So essentially warehouse 2 and everything is being serviced by a warehouse within 10-minute drive time. So if you actually look at this, nothing is more than 10 minutes. So this can be used as an input in your logistic operations on allocating warehouses and so on and so forth, so that you get the match. So another thing that is pretty obvious from these two service area and OD cost matrix solvers is the type of predefined layers that are added to the map every time you do this. So you in the OD cost matrix you have origins, destinations, and then polygon barriers and line barriers and lines. When you look at the service area facility, you have facilities and polygons and polygon barriers and lines and so on and so forth. So just to clear it up, because these will change depending on the type of solver you are using. So moving on, let's open tutorial 6, is it? Tutorial 9. Let's open tutorial 9, which is choosing an optimal store location using location allocation. In this exercise, what we'll do is we are managing a chain of retail stores, and we will actually choose the stores that are going to do the most business, and the main objective is to locate stores close to population centers, so that you get the maximum, you get the maximum business out of them. So how do we do that? You'll also will be performing location allocation based on 3 different problems. One is maximizing attendance, which is maximizing your profit, maximizing market share, and also target market share. So we'll see how that's done. The first step here is to actually see that the dark purple are existing stores. There is one existing store, and then there are candidate stores here. So these are not, you only have one existing store so far, and then you have candidate locations for other stores, and you have 3 existing competing stores. So you need to watch out for these locations, because these are likely going to cut into your profits or your customer base, which is also called cannibalization, but we'll talk about that later. So the first step here is to click on network analyst, click on a new location allocation problem, and the facilities are pretty clear. So the facilities, for the facilities will be using candidate points, candidate stores. So we'll go back to the map. For the facilities, click on load locations, and then we'll use candidate stores as our potential, and then give it a name. Click on OK. So you have 16 possible store locations starting from 1 through, actually we have 1 through 19, something like that. Anyways, so the next step here is, let's look at what the next step is. So the next step here is to add demand points. So the demand points are essentially your track centroids, which has business count, population counts, and so on and so forth. So I'm going to right click and click on load locations, and the demand points will be existing store, no track centroids, and then we'll be using for the weight population 2000 as our weight. So these points will be weighted based on the total population of each census tract centroid. Click OK, and you'll have all these points added as demand points, and about 208 demand points. So each one of them is given the census tract name, which is fine. So the next step is to look at the analysis settings. So let's look at analysis settings. It is in travel time, and travel, make sure that the impedance is set to travel time, and you also need to make sure click on U-turns are allowed and straight line, and make sure that facility to demand is what it is selected, because that's what it is. These facilities are serving the demand points. And then also under, make sure your window looks like this, like where you're using hierarchy and ignoring invalid locations, and then you're using restrictions on one-ways and restricted turns. And then you will be click on advanced settings, and then the problem we are trying to solve here actually is maximizing attendance. So that's the first type of problem we are solving. So we need to access we need to place the stores in a location where you get most number of customers. So let's do that. And then number of facilities to choose, let's increase that to, let's find 3 stores, not just 1 store. You can change that, and also increase the impedance to 5, meaning that people are not really willing to travel more than 5 minutes to actually to shop at these stores. So how do we do that? Just turn it up to 5, and then the impedance is linear, and then by linear impedance, what it means is that if you click on this, it essentially means that the probability of a customer going to this particular store is indirectly proportional to the distance. So if the distance is higher, probability goes lower. If the distance is lower, probability goes higher. So that kind of a thing. It's sort of like a gravity model. So since I got all my options, I'm going to click on apply, click OK, and I'm going to go ahead and solve this. So essentially what it does is just ignore that. So it essentially gave me 3 candidate locations based on your existing well, it is not actually taking into account existing store locations, but based on the population itself. So looks like those are the 3 best locations, although I highly doubt this location is the best location. Essentially it is located right in the middle of your competitors market. So again, that's the kind of thing you need to correct for. So let's see. So let's look at the facilities attribute table. Now you can see the facilities 3, 5 and 6 have something called demand count, which means out of the 208 demand points, it is actually serving how many? Statistics. 114 of them. The rest are not served because they are outside a 5-minute drive time, 5-minute travel time. And then each store has a demand which actually shows how much population it is serving. So if I click on that store is going to serve 95,000, which is the most. but then again this model did not take into account the existing competition. So let's, with that in mind, let's also look at demand points once. So this has something called a facility ID field, which these points have been allocated if I sort them by ascending order or descending order. So all these points are being serviced by the facility number 3. So as you can see, the points have been highlighted here, which are being served by facility 3. So anyways, this kind of information keeps getting updated as you keep running your models and so on and so forth. So that's that. So what we'll do next is, so now as a second scenario, what we'll be working on is you'll use the location allocation to solve store expansion scenario, in which you'll start an existing store and optimally locate 2 additional stores. How do we do that? How do we take into account existing store? I'm gonna right click and go to load locations on facilities, and here what we are going to do is select existing store from load location. Existing, let's select that. Actually, why don't we, let's go ahead and use existing location. Click OK. Actually, let's go back to the load locations thing, and then here the existing store is not it's not a candidate, it is in fact required, because required means existing. So I'm going to go ahead and do that. So you see how the symbol changed for the existing store. Now what we're going to do is we'll go back to our analysis settings, and then here maximize attendance and make sure it looks the same, and then let's rerun this analysis and see what happens here. So essentially what it's doing is, before it gave us this location as probably the best location, now it has slightly changed, because it says your existing store is gonna do, it's gonna cover this market, and then these 2 stores are gonna bring you additional, it's gonna maximize your attendance, since you are going to add only 3 stores in addition to the existing store. Like in addition to the existing store, it's gonna be only 2 more. So that's going to be your next 2 candidates. So you can go back to your facilities, look at the candidates weight and so on and so forth. So that's going to do service 94,000 people. So again, that kind of analysis takes into account existing stores, but we need to account for competition as well. So I'm going to right click on facilities and click on load locations, and I'm going to choose competing stores, and the facility type is actually competitor. So I'm and what else? So I'm going to click on OK. So as you can see, we have 3 competitor stores with a different kind of symbology. If you want, you can change the color or whatever, it doesn't matter, because it's already being served. So what we can do is go ahead and solve this problem now and see how that changes the entire model. So taking into account existing existing store locations and existing competition, these are your next 2 stores. But let's try and, instead of actually maximizing attendance, we should maximize market share, because there are existing stores now. So let's reduce the impedance parameter to 2. So here let's change the impedance transformation to power and parameter to 2. and then try and run the analysis. If you run this, you're gonna get a completely different set of results. As you can see, it's gonna sort of like list out all the facilities that are being these are the facilities. Let's look at the demand points and the demand points which are being served by the facilities, and so on and so forth, and allocated weight. So as you can see here, you have the existing competition, and your existing stores are, your competition is doing slightly better, but your store 14 is gonna do a lot of business for you. So if you are going to face a prioritize, this will be your top store, the next top store, and that store location will be your that's sort of your existing store, which is also doing pretty good. I'm sorry, what is that store star? Okay, these are your chosen stores. So these are your 2 next best stores, and these are your existing stores, and that's how you actually solve the problem of actually location allocation using market share. So let's also run a scenario where we are trying to achieve a target market share. So let's go back to your analysis settings, and here let's say target market share. So we are trying to achieve a market share of 70% because we are pretty ambitious. We want to achieve 70% of the market share. So let's see how we can do that, and essentially solve the problem. What if we want to so based on that, based on those settings, so since we did not get any messages, let's go back and change messages to all messages. Click apply. Let's solve this again and see what happens, and see how much market share we achieved. So it says number of facilities chosen is 9, and market share attained is 71%. So essentially it is saying you need to open 9 stores to achieve a market share of 70% based on your existing candidate locations and competition and demand points and all that. So that's how you actually solve your analyze your market and come up with real estate strategies, so to speak, on which stores to open and which stores to close, and so on and so forth. So that's your sort of like a brief overview of network analyst. Let's move on to exercises 5, 6 to 5, 9.